Let's go through Liquid 692 top K frequent words. And for this question, give us a string array words and a K. And let's find the top K frequency words. Let's say that sort the words with the same frequency by the lexical order. So we are going to use, there are a lot of ways to do this, but any of the way we need to have the user map to count the frequency. We are going to use a bucket sort to do this kind of question. So we are going to count every word by its frequency first. It's a default word then plus, right? So this first thing we are doing, let's have this word of length. And we are going to use a bucket for buckets equals new list in classroom. We know there are n for the words, the length is n, right? So the frequency can be 0 to n. So we use n plus 1 buckets. So what we are going to do is that for every entry, right, map entry, the key will be string. So value will be integer entry in map about the entry set, right? We'll have bucket. But if this bucket I is not a bucket, I equals to now, then we'll have buckets I equals new array this, and we'll have a buckets I. This is not I, right? So it should be we have the frequency. Let's do this count. Int count equals entry dot get value, right? And string word equals entry get key. So we'll say well, for this count, we put it in this bucket. So let's say if this bucket, this is now, we'll have this one to create a new array list. And we'll have this one. Add. So we are going to have a list of string as a result. First new array list. Okay. We can have an index as 0, right? So we'll have for int I equals n I greater equal to 0, and we'll have this kind of condition a bit later. I minus and list string. We'll do this. If for this bucket I equals to null, right? Means for this bucket it's empty. There is no words. Just continue. And we're going to have list of string list equals new buckets, BUCK buckets I, right? It need to be sorted in lexical order, so we need to have a collection sort list, right? And we have for enter j equals 0, j is smaller than list dot size, okay, and j plus plus. We have result add actually even this index we don't need, right? So we just need to for string word in this kind of list, right? So we'll have result add this word, right? And we'll use the index to count how many we already have, right? So if we have index equals k, then we just break, right? And here we can also have this kind of condition, index smaller than k, right? Then we just return result. Okay. For this kind of method, because since there is a sorting for the lexical order, so we know this so we'll say averagely this kind of list depend on the average set how the data is distributed. If it's kind of even, this will be let's say the average constant size of the list is for example m. There is a log m coefficients for the time complexity. For the other operation, it is O(n), right? And a space that is linear, that is the O(n) space complexity.